Hi, good morning. Um, Today we're going to talk about the instruction fetch cycle. Alright, in the previous section we were using the program counter as a way to retrieve the values we were adding. That was sort of convenient just for learning purposes. We were just trying to get you interacting with the CPU quickly and not necessarily having to understand how the instructions work in detail. That's going to take a little more time, so let's talk about that. In reality, instructions are loaded from RAM and then executed. So we have a need to retrieve and decode the instruction. That is, we need to figure out what we need to do and then do it. Getting the CPU ready to execute an instruction is called the fetch cycle. It's basically the overhead or prep work that each instruction needs before the CPU is able to execute it. Luckily for us, that procedure is the same for every instruction, so we can kind of reuse that algorithm. So what exactly are those steps? I think the best way to understand the fetch cycle is to go ahead and do it manually. However, before that, we need to load a single instruction into RAM before we execute the fetch cycle procedure. So we're going to go ahead and put that instruction in address 0. We also need to store 28 in RAM as well. Previously we had put it in address 1, but now we really need to get it out of our way for instructions, so we're actually going to put it at the end of memory in memory address 14. Alright, so let's go ahead and cycle the power button, or you can just refresh the browser, and that will ensure that the emulator is cleared and ready to go. Okay, and using the RAM's manual input, let's store this value into RAM address 0. So this is going to kind of be a secret value, which is basically our instruction, but we'll get into what that value actually means in a little bit. Also, then using the RAM's manual input, enter the value of 28 into RAM address 14. Okay, and go ahead and hit reset one more time. RAM will be preserved, and go ahead and enable the halt on the clock, and then that will get us set up and ready to go with the fetch cycle. Alright, let's go ahead and execute the fetch cycle. We need Mars address to reflect the value in the PC as our first step. So let's enable PC's CO control line, and we're going to see that that value goes immediately to the bus. Next, we need to enable Mars MI, memory in, and this will receive the bus value on the next clock pulse. Okay, so go ahead and pulse the clock, and we see that the MI latches the value from the bus. Okay, the next thing we need to do is we need to put the value of the current instruction into the instruction register. Okay, so disable all the control lines from step 1, but not the clock halt. Okay, then go ahead and enable RAM's RO, or RAM out. Then you'll see that the instruction value goes immediately to the bus. And then enable IR's II, or instruction in, so that it will latch value from the bus on the next clock cycle. And then enable the program counter's CE, and this will also increment the instruction counter on the next clock pulse. So we're going to kind of be doing two things with one clock pulse. So go ahead and pulse the clock, and we see that the IR value is latched, and also the PC's counter is incremented. So then go ahead and disable all the control lines except for the clock's halt. So now, as a kind of an end result, you should see the instruction register has taken in the value we stored in the RAM's address 0. But before we get too carried away with explanation, let's break and start another section so we can properly talk about the instruction register. Alright, thanks for watching. Since it's morning time, go get your second cup of coffee, and I'll see you in a bit. Have a good one.